This is lesson 2.6, and we are going to be writing proofs. And it's very important that you listen to the audio of this video, because if you don't, it's not going to be helpful to you. There are some very important tips that I'm going to be giving you, so please make sure that you leave the audio on and actually watch the video and listen to all the things that I'm saying so that you have an idea of what proofwriting is all about. The vocabulary at the top of your note sheet. A proof is a logical statement that shows a statement is true. So we're going to be writing proofs, and specifically we're going to be writing 2-column proofs. And similar to what we did in lesson 2.5, we're going to have some statements on the left, and then we're going to give some reasons on the right. And those reasons have to do with all of the different properties that we're talking about in each of the diagrams. There's going to be some specific reasons, definitions, things like that that we can use to prove that statements are true. So this 2-column proof has numbered statements and corresponding reasons that show an argument in a logical order. A theorem is a statement that can be proven, and we haven't actually proven those theorems, but we know some theorems. And here's a theorem here, 2.1. It's the congruence of segments. So segment congruence is reflexive. That means that segments are congruent to themselves. They are symmetric. We can switch the order and they're still congruent. And they are transitive. So we know those because we wrote them in our theorems page, and also we talked about them in class. Same thing for theorem 2.2. Angles are reflexive, symmetric, and transitive when we're talking about their congruence. So when we see these things in our proofs, we need to be able to recognize that it's okay if angles are congruent to themselves, if we switch the order of them, and if we use them to say that they're equal to other things, but then two of them can be equal to each other. So we know about transitive. It's kind of like the law of syllogism. All right, the definition of congruent segments. If a segment, let's just say AB, is congruent to CD, then we know that the length of AB is equal to the length of CD. Now the idea here is that you see this congruent symbol in this first part of the statement, but you see an equal sign in the second part of the statement. So if for some reason you see that the same information, AB, segment AB, is congruent to CD, so they write it one way the first time, and then the second time they write it without the bar over top of it, and they have this equal sign, then we're going to use this as a reason, definition of congruent segments. So it's really important that you realize that this is going to be used when the equal sign is replacing the congruent sign. Definition of midpoint, we're pretty clear on that, I think. If M is the midpoint of a segment called AB, then that means the segment AM on that line is congruent to the segment MB on that line. So let's just say, for instance, here's our line, segment, and here's A, and here's B. If the midpoint is M, then that means that this segment is congruent to this segment, and so that's the definition of midpoint. All right, we're going to start our first proof. Example number 1 is asking us to write a 2-column proof, and so there are some tips that you want to pay attention to. For instance, whatever we're trying to prove is always going to be written as our very last statement. And whatever we've been given is going to be somewhere in the statements. Generally, the first thing is going to be what we're given. So look and see what you're given, and wherever that information is written, you want to say that that's the reason is that you were given that information at the beginning. So it looks like we have AD is equal to 8 and BC is equal to 8. And often I'll go ahead and write that information on the diagram as well, so that when I'm looking at the diagram, I can see exactly what I've been given. So in any proof, they're going to have 3 things. 1, what you're given. 2, what you're trying to prove. And 3, you're going to be given a diagram. So you're always going to have those 3 things. And then there's going to be some statements on the left Those are the things that you need to give a reason for. Reasons are going to be things like definitions, theorems, postulates, things like that that can be written as your reasons. Okay? And then it says here in statement number 2, segment AD is equal to segment BC. And basically what we have here is the transitive property, because if you remember from statement number 1, 8 is equal to both of those things. So if 8 is equal to AD and 8 is equal to BC, then that means that BC is equal to AD. All right, and that's where we're going to write the transitive property. Remember we said if one thing is equal to two other things, then those two things are equal to each other. And that's the transitive property. Segments, you can use the transitive property for segments and for angles. Okay, now we have something a little bit tricky. Remember we said that if the equal sign changes to the congruent sign, but everything else is the same, then that's going to be the definition of congruent segments. All that changed was that symbol. Okay, so we're saying that because they have the same length and value, they are congruent. All right, and then the next statement says that segment BC is congruent to segment CD. If you go back to the top of our information here for this proof, we see that that information was given to us. So we're just going to write in the word given here. Often at the beginning of the proof, I'll look and see if anything is given to me, and actually anything that is given at the top will always be stated in the proof. So I should have recognized that this information was one piece that would be given, and this was a separate thing that we should also have. So remember, statement number 1 was given to us, but if we looked a little bit further, we would have seen that that was also given to us. All right, so the last statement is what we're trying to prove. I never want to write the word proof at the bottom, though. There has to be a reason for number 5. You can't just write the word prove. Well, how did we arrive at this segment AD is congruent to CD? Well, in statement number 3, we said that AD was congruent to BC, and then statement number 4 said that BC was congruent to CD. So that means that we said something about BC in both of these. And if that's the case, then that means that we can cross those off and leave the statement stating that AD is congruent to CD. And if we cross things off and we make a new statement with the things that are remaining, that's going to be the transitive property. All right, so now we've done our first proof, and the next proof on the page is for you to practice on your own. And just remember that I gave you lots of tips about which reason you can use. And to start off with, of course, you're going to start with things that were given. I'll give you a hint. There are 2 of these reasons over here on the right that should just say the word given. Okay, so 2 of your reasons are going to say given. And then there are 2 other reasons that you're going to use. They're a little bit different, and if you can't get them, we can go over this in class, but please make sure you make an effort to try this first proof on your own. Another suggestion is that you actually mark up the diagram so that you can see exactly what you're dealing with, and remember that you have to give a reason for number 5. You cannot just write the word prove there. On the back side of your paper, we have a couple more proofs, and then also we want to, in example number 2, we want to name the property that is illustrated by the statement. Now the choices, and this is going to be true for the on your own practice as well, choose from reflexive, symmetric, and transitive. So these, remember, we learned in the previous lesson. So we just have to remember what each of these means. And in example 2, statement A says if segment XY is congruent to segment WZ and WZ is congruent to PQ, then XY is congruent to PQ. So if I look here, WZ is stated in both of these statements of congruence. So if I cross those off and look and see what's left, xy is congruent to pq, then remember that's the transitive property. If two things are equal to each other, after we remove something that's been repeated, then that's the transitive property. You might also remember that from the previous lesson where we were talking about the law of syllogism, which is a deductive reasoning skill or task. All right, so statement B, if angle M is congruent to angle N, then angle N is congruent to angle M. So all we did was we switched the order when we stated it in the conclusion here. So when we switch the order, that is the symmetric property. All right, and then you're going to do numbers 2 through 5 on your own. All you're doing again is using the 3 choices over here, and you're going to make a decision on what each of those statements, which property each of those statements is using. And I'm going to go ahead and do example number 3. Now this one has to do with angles, which, you know, all it is a little bit different geometric figure, but we're still allowed to use all of the same reasonings and all of the same postulates and things like that. So we're going to take a look at what we've been given. Remember, you're always going to be given 3 things. You're going to be given the statement that you're given, what you're trying to prove, and then of course a figure, some kind of diagram to look at while you're making this proof. So at the very beginning, in our first statement, it says that angle A is congruent to angle B, and angle B is congruent to angle C. Okay, so if I've been given that information, I just need to write in the word given. We do not write in the word proof, though, at the bottom. Okay, so make sure that you give an actual reason. What you're trying to prove, then, is angle A is congruent to angle C. All right, so in the first statement, we notice that there is a congruent symbol here and a congruent symbol here. But when you look at statement number 2, the measure of angle A is equal to the measure of angle B. So up here in statement 1, there was not an M, okay, and now we have an M here. There was not an M for the measure of angle B here, but now we have one here. All right, and previously we were talking about segments, but when that symbol changes from an equal sign to a congruent sign, or vice versa, that's going to be the definition of congruent angles. Just like we had in the previous one that I did on the front of the page, we said definition of congruent segments. Anytime that symbol changes, it's going to be the definition of congruent and then whatever the shape is. This one happens to be angles. All right, and then in statement number 3, we have the same thing again. Remember up here, it just said that the 2 angles are congruent, but down here, now they're saying that the measure of that angle is equal to the measure of the other angle. And when we see that symbol change, we know that that's going to be the definition of congruent angles in this case, because we're dealing with angles, but if it was about segments, we would say definition of congruent segments. So just remember, the symbol changes, we go immediately to that reason. Okay, so in statement number 4, previously we had said that this angle B was part of both of these statements. Okay, so since angle B is congruent to angle C and it's equal to angle A as well, we can then just say, okay, let's cross that off and write out what is left, which we did here. So that's the transitive property. Anytime we see a repeated information, and then we rewrite the leftover information, that's the transitive property. All right, and finally, we see that the symbol has changed again. We had an equal sign here, and now we have a congruent symbol here, and when we state that something is congruent, that's just slightly different than saying that the measure of something is equal to the measure of something else. And like I said, when that symbol changes, we want to go ahead and write in the definition of congruent angles. So we just had to use a couple reasons, but we had to use them multiple times here. 1, 2, 3 times we used that. and the transitive property, which we know sometimes looks like the law of syllogism. Okay, so you're going to be doing this next proof on your own. This one has to do with segments. It may be very similar to the proof that we just did using the definition of congruent segments, okay, and the transitive property. So those are just some hints, but look at each statement carefully, and if you're not sure, then make sure you're doing this in pencil and ask some questions, because proofs can be very tricky. So I'm not expecting that you're going to be perfect at it, so just be patient with yourself, and we'll do lots of practice in class.